couple of weeks ago, Bang had contacted me and they sent me this email up here. It said, I've been following your work on YouTube for quite a time and I'm impressed with your content, very informative and engaging. Well, thank you very much. And they asked me if I would like to take a look at this, which obviously they've since sent me. This is the Gochifix LG303 oscilloscope in a multimeter form factor. And it is actually a multimeter as well. So I was interested because quite often as a PA engineer on site, I've needed a scope or wanted a scope to be able to measure audio. And it's not practical to carry this around on site, is it, really? So, yes, I thought I'd take a look. Here's my tool bag that I have to carry around with me. So if this thing fits in there, then I'm happy. And actually, this is a 3-in-1. It's an oscilloscope, multimeter, and a signal generator. So possibly I don't have to carry that or that as well. So let's put this to the test and see how well it performs. All right, let's have a look. So first of all, I'm not getting paid a single penny for reviewing this, so this will be unbiased and completely honest as always. So I've put the meter back in the box. I have had a good play with it already. I've tried to repack it as it came so you can see what it's like if you choose to buy one. So it's a cardboard box, you can see, and inside you've got the meter inside a silvery case, quite nice. A USB-C lead, which is for charging. You've got your probe leads there, your test leads. We'll have a look at those. And quite nice feature, you've got a kind of a quick start guide here, which help you get up to speed pretty quick. I'm going to go through all of these, every single setting on here. I'm going to go through and we'll look at them in more detail. But I like that. You don't get that very often. And on the back, there's even more. I haven't read through this. I've gone through it myself. Actually, this is German by the looks of it. So that's the English version, and I believe that's German. And you also get a fairly concise user manual as well. It goes into quite some detail. Again, I haven't read through all of that, but it does look fairly good. A lot of detail in there that you don't often get these days on, lower cost products. Yeah, quite impressed. But let's get to the important bit first. Let's have a look at this meter. So get this silvery case, take it out, and there you go. So the first thing I noticed, it is very light, but I got used to it, and I first of all, I was put off by the weight because you like things to feel a bit substantial, but you got this nice rubber boot around it, and it feels really quite nice. And if I was working on site with this, I would feel fairly confident in using it. Now you've got a kickstand at the back, which has two positions, so you can have it like that. There's kind of an indent there, and it stops at a second position, so you can have it more upright. I think I would probably have it here for the height of my seating versus this desk. That angle was just right. If your desk was higher and your stool lower, then maybe you'd have it on that angle, or you could of course have it flat. The size of this is, I'll just put my ruler here. The height is about 160 millimeters, or I can see on my chart there that's 6.3 inches in American money. Or on the width, it's about 75 to 80 millimeters, something like that. And that's 3.3 inches. And the depth is just 34 millimeters, something like that. And the depth in inches is 1.3 inches, okay? And it's very light, as I said. It's actually 0.44 pounds or 200 grams, all right? And let's have a quick look at these test leads. Now, typically, test leads that you get that come with meters are not that great, so let's have a look. And they're not too bad. They're actually quite flexible. Not quite to my ProbeMaster standard, but of course you pay a premium for those, and you can use your own test leads, of course. You don't have to use what comes with it, but these actually look all right. It got a 90, not quite a 90-degree angle on the leads there, so let's just see how that fits when this is standing upright. So if that's like that, then yeah, that sits okay. Not too bad. I've had these before where your meter's kind of sitting like that and it's pressing against it, and it's horrible. That seems to have been designed right. It does fit. Let's try the common because that's lower down. Yeah, that's okay too. Now the other thing that I noticed on this meter, and I see other people that have done a review, that this is an oscilloscope, so you'd expect to see a BNC oscilloscope probe contact point on there, but there isn't one. You actually use your test leads, which is nice and convenient. It's actually quite good that there's no exposed metal parts on the meter, but using these for oscilloscope purposes is far from ideal. There's all kinds of capacitance and inductance and everything going on with these, so it's not ideal. But I do have a solution to that, and we will come on to that later on this video. Just go through these settings first of all. So you've got volts mode. There you go. I do like that display. It's subjective, I know. Some people like it, some people may not. I particularly like it. It's very, very clear. I can see it from lots of angles here. Yeah, that's an unusual kind of display, but I do like it. Now, you can't really see on the camera here. I'll try and get a shot of this later on. My lighting is probably drowning this out, but you've got a coloured LED here, here, and inside the dial here, and it changes colour as you click round. So you've got volts, millivolts, ohms, capacitance, frequency and duty cycle, microamps, which is good. Don't always get microamp setting, milliamps, 10 amps, and another off position there, which I quite like. You haven't got to go all the way back round. So if you was here and you want to turn it off, it's just a couple of clicks rather than having to go all the way back round. All right, I like that. So what we're going to do now is I'm going to go through each of these settings in turn, and then we go through the oscilloscope and the signal generator functions. It's got a save facility, so you can store all your readings or waveforms. And if you want to jump to any of those rather than watch the whole video, then look in the description below. I will put a schedule of times that you can skip to. All right. So let's just take a quick look at the specifications then. It's a multimeter, oscilloscope, and a signal generator. The multimeter supports AC and DC, of course. It measures resistance, diode, capacitance, frequency, duty cycle, continuity. It's 6,000 count meter, which I'll explain later. And you can store your measurements into, you've got 100 storage positions that you can record volts, ohms, amps, or whatever. The oscilloscope is a 50 megasamples per second scope with 12 megahertz bandwidth. We'll be checking that later. And you can store 10 lots of your waveforms that you've got on your scope. You can store them away to review later on. It's a signal generator supporting sine, square, and ramp, anything between 100 to 100 kilohertz. And there's a rechargeable lithium battery inside this thing. There's a USB-C port over there. Now, unfortunately, it's not available in the UK, but in the US, it's just under 90 bucks at the moment. But if you watch to the end of this video, I do share you a promotion code and you will get a further 25% off. So that's good. So let's just start with the voltage setting then. You turn your rotary wheel to the V position, and then this rotary wheel will turn red, as I've shown there, and the two side panel LEDs will also turn red. You must connect your test leads here and here, red lead here and your black lead here. And when you put it to that position, these function keys will have these functions. This changes depending on which selection you've made here. So the F1 key is that, the F2 is that, and F3 is that. And let's just look at that closer. So F1, which is rel, that stands for relative. F2, which is pH, that stands for peak hold. F3 is cell, that stands for select, and F4, that's RNG or range. And when you select them, you get these options below it, basically. Let's just go through them. So if you press the F1 key, that would turn the relative function on or off. So relative is where you take your current reading, and any reading that you're measuring after that point will be relative to that. So if you, I don't know, if you measured 1 volts and you press relative, then any measurement you take after, let's say you got 2.5 volts, and it would actually read 1.5 because it's the difference, okay? And that's quite useful for zeroing out your test leads, and we'll do a demo on that shortly. Then peak hold, well, that records the upper and the lower reading of whatever test mode you're in. So in volts, it'll give you the upper and the lower voltage that your meter's seen. If you're on resistance, it'll give you the upper and the lowest resistance in terms of ohms that it's seen. And you can stop that and go back to normal, or you can reset it, start again, and then of course you can exit back to normal mode. Under the select button, it starts off at DC, you press F3, it'll go to AC mode, you press F3 again, it'll go to frequency, and F3 again goes to duty cycle. Now you can actually measure frequency and duty cycle over here on this rotary option, but I guess it's quite handy because if you're on AC and you're measuring, I don't know, mains voltage or something, it's quite useful to reassure yourself, yeah, I'm getting the right frequency of that, 50 hertz or 60 hertz if you're in the US, and you can check the duty cycle of it as well. Then range, as I said, this is a 6,000 count meter. It's got auto range, and that's its default position as soon as you turn to the voltage mode. But if you press F4, then you will start to step through these options, and I'll explain that when we do a bit of a bench test. And if you want to get back to auto, because you see it goes to 600, 6.00, 60.00, da-da-da, then 1000, then it only comes back here. If you want to get back to auto, you just press the auto button. So now we're going to take a look at this on the bench. So we go, I've selected volt mode, it's currently on auto range, and it's selected 600 count. I'll explain what that means in a little while. And it's on DC, and yeah, let's just see how accurate this is. Now I've got my little precision voltage reference here. I like this, it reminds me of ORAC out of Blake 7. Yeah, Blake 7, you may remember that.
I did not lie.
So I'll just use these leads to connect up. So put that in the positives, turn it on, and positive on the meter, common, and common on there. And you go into these two connectors, as said, for voltage range. So currently I'm on my 10 volt setting here on the voltage reference, and I'm getting bang on 10.00 volts. Brilliant, very accurate. Now let's drop it down to 2.5, and I'm getting 2.505, very close. And then 5 volts, so I'm getting 5.006, very good. It's oscillating a little bit. Yeah, that's pretty accurate. And 7.5 volts, bang on again. So that's not bad at all. So just quickly talk about this thing called 6,000 count then, in case you're not familiar with it. The count on a meter is to do with its resolution. It's how many digits it can display effectively. It's not the accuracy, it's just how many digits display. You could have loads and loads of digits here, but all be wrong. Okay, so it's not a critical element. It's a good factor of the meter, but it's not the critical element. The critical element really is the accuracy of it. So at the moment, I'm using my programmable power supply, which is over to my left here, and I'm got it set to 0.6 volts, and there you go, it's almost 0.6 volts. This is on auto range, and it's gone to 6.000 count there, so it can display 3 decimal places in that range. But what will happen is, if I slowly increment the voltage here, once it gets to 6, unfortunately you then lose a digit, so you would get 0.6 point whatever it is. So let me just do that. I'll slowly increase this by 1 volt, and you'll see what I mean. So there you go, I'm on 1.6, 2.6, still got 3 digits, 3.6, 4.6, 5.6, and still got the 3 decimal places. Now when I get to 6.6, there you go, you lose 1 digit. So you've lost some resolution. And that's just a limitation of the the processing in the meter, and it's the same with all multimeters. If you want to change the range yourself, this thing here, it boots up in auto range, but you press this F4 key because that's where this RNG stands for range. Press once, it'll come out of auto, press again, and then it'll cycle through all of the various modes that it's got. All right, so you can see the number of digits changing there. Okay, so that's multimeter count. And this F1 key, currently it has REL up just above it there. So that's telling me this is the relative function. So I'm currently feeding in 5 volts through here. And if I press REL, this F1 key, then you see this goes to 0, but my reference point, which is stored there, you might just about see that on the camera, my reference point is recorded the fact that this now is relative to 5 volts. So if I start to increase my power supply output 1 volt at a time, so that's 1 volt, there you go, it's telling I'm currently putting 6 volts out, and it's telling me I'm 1 volt above my reference. And do it again, so 2 volts, there you go, 2 volts above my 5, 3, and so on. And if I go the other way, down to 2, down to 1, down to 0, so I'm back to my 5 volts, same as this, so it's 0 difference. Now I've gone to 4, there you go, I'm 1 volt below it. Okay, that's quite a handy feature. And a kind of alternative way of doing something similar to that, because this meter's got loads of functions actually, as I've navigated around and found out for myself. So currently, again, I've got 5 volts coming into here. And if I just click this save button once, it's kind of stored away this 5 volts now, and my instantaneous reading, the voltage that's coming through here at any one moment in time is here. But this is going to be retained. So if I start to increase the voltage, so I'm at 6 volts, there you go, this is now giving me 6 volts up here, but this has left my display at 5. So going up 7, going up 8. Yeah, so this is increasing and this is staying the same. That could be handy in various instances, and I've not seen that before, so yeah, good feature. And another function of this save button, rather than just press it the once, if you hold it in for 2 seconds, and I really like this, then you've got 100 entry points where you can store your readings. So there's multiple pages here, so you navigate so that these kind of down arrow, a right arrow, this says erase and this says save. So if I go to the right, you can see it goes each page, and you've got 59, up to 69, 79, 89, 99. So you've got 100 positions here because it starts at 0, of course. And if I press save, this F4 key, there you go, it saved my reading that I've currently got. Now that's brilliant for me because quite often on site, I'm going through some terminals in a rack and I'm getting one reading on these terminals and I'm having to write that down, another reading, write that down, another reading, write that down. And this would save a whole load of time, and you've got the full reading there. And you could use this as evidence that you did actually get that reading, you haven't just written it down. Okay, I like that. And then to come out of this, you hold the save button again. There you go. And we'll do some more saves and you'll see how it stores all the various readings that you can do, ohms, you can do current, all kinds of stuff you can save into those 100 positions. And just look at this PH, peak hold, and that's assigned to the F2 key when you're in this mode, and indeed some of the other modes. If I press that, so I'm currently got 5 volts coming in. If I press the PH key, there you go, it's now running. So it's telling me the minimum voltage that it's currently seen is 5.001 volts, and the maximum it's seen is 5.001 volts as well. Now, unfortunately, when you do select this mode, I found that the auto range disappears. So you're kind of fixed in the mode that you started at. So it's currently running. So these will start to change as I adjust my power going into it. So if I start to increase, so I've got minimum 5, maximum 5.001. If I go up, there you go, my maximum's gone up. Going up a bit more. There you go, so you can see this is now 5.596 is the maximum that it's seen. This would be good for monitoring a voltage input coming into a device and you're concerned that maybe it's going out of its limits, but you don't want to sit there watching it for hours and hours, monitoring it. This could do it for you. Then if we go down, this minimum should start to reduce, okay? So unfortunately we're at 6.000, and I don't know why the meter does this. I've not got my head around that, but it doesn't retain the auto when you're in this peak hold mode. So if I go up, right up, hold on, let's just go up a volt at a time. Yeah, then you're on overload, look, so you can't unfortunately go into alternative range. I've gone back down again now. All right, and then you can either stop this functionality or reset it back. So it just go, if I press reset, there you go, it's put the min and max at its current reading. Or you can stop it, so you've kind of frozen those readings, and then to come out of this mode, you press exit. All right. And the F3 key's currently got SEL, or select. That allows you to select the various modes that are available under this volts selection here. So if I press it once, I'm currently on DC, press it once, then it goes to AC. If I press it again, it goes to frequency in hertz. And if I could press it again, it goes to duty cycle, which is measured in as a percentage. So let's just go back to AC. There we go. And I've got a little AC transformer there. So if I stick my probes on and here, then I'm getting 14 volts AC. Brilliant. Now if I press again, and now I'm on frequency, now it's picking up, yeah, it's picking up frequency through my hands, and the probes there has gone back now. But if I put that on, the AC frequency in the UK is 50 hertz, and there you go, bang on 50 hertz, not bad. And then if I go to duty cycle, that should be 50%, of course. And yep, not bad, 50%. There you go, UK current supply, pretty accurate, okay. And if we now click round one more to the millivolt range, you see the LED now changes to this kind of magenta colour. And the only difference between the voltage and millivolt range is, well, first of all, you don't get the frequency and duty cycle on your select button because it's meaningless in DC, and the range that you can select is obviously reduced because you're in millivolt range. And let's just take a look at that at the bench. So there you go, I'm on the millivolt range. Now, the sun's just coming out here in the UK, which is quite unusual. But if I press this button here, you can see it's got the sine wave, which does something else in a different mode. But also we've got this sort of sun symbol here. And if we press that, you can see I can increase the intensity of the backlight on that LCD. That's probably better now. So I've got some millivolts coming in from my power supply here. And if I crank that up and down, you'll see the reading going up and down. It's in the millivolt range, okay. All of this stuff behaves exactly the same as if you was in the volts range. And the only difference, as I said, currently in auto, but you've got less options on the range selection there. All right, that's millivolts. And now if we just click around one more and go to the ohms or resistance range, then you can see the LED goes to this yellow colour. You still get the relative function, you still get your peak hold function. The select button, however, you can go through these three modes. So it defaults to resistance when you clicked here. You press this once and it go to diode. You press it again, you go to continuity. Press it again, it go back to resistance. And then you got the same options on your range there. So it defaults to auto. You press range, it go to 60. Press again, it goes 600. Press again, it go to 6.000. So let's take a look at that at the bench and do some testing. Right, so when you switch to the ohms range, even though you've got several modes here, it defaults to resistance, which is what you'd expect. And let's just test a few resistors there, see what the accuracy is like. My stock of precision resistors is not huge. I've got a few in here. So let's start with this one, a 10 ohm, 0.1% metal film resistor. So let's measure that. So we're expecting 10 ohms, just click that on. And we're getting 10.2, not bad. Okay, so that's 10 ohms. And now step up to 100 ohms. Again, 0.1% tolerance, this resistor here. And we're getting 100.1. Now, just to try something here, let's just clip these together. Yeah, I thought so. So my leads have got a 0.2 ohm resistance. So this is where the rel function comes in, or relative. So if I press that now, That will zero that out. It's got minus 0.1, but you get the idea. So it's now relative to 0.0 0.2 ohms, which is roughly the resistance of these leads. Now let's try, see what we get. So let's try that. There you go. Yeah, look, bang on, 100 ohms, so much better. Okay, so that's 100 ohms. And we won't try that because that's 1%. Another 0.1%. So this is 4.7k resistors here. Just separate that out a bit, see what we get. That's where, when you press the rel, it won't auto range. So you're going to have to turn that off, put it back into auto. And there we go. So now we're up in the right range. I don't know why the meter does that actually. Bit of an annoyance, but it's okay. So I'm getting 4.701, and I've taken off my rel, of course. So you've got to take into account the resistance of these leads. So 4.701, pretty good. And that's 4.7k. What else have we got? We've got 18k, again 0.1%. Let's try that. Bang on, 18k, all good. And I think the final one I've got here is a 200k, again 0.1%. Oh, that one looks a bit corroded, so we'll do this one. So this is a 200k, yeah. And we're getting 200.1k, excellent. Right, and when you've got your rotary selection on the ohm setting here, then all these buttons do similar to what they did during voltage. Rel certainly does, peak, hold certainly does, and range, well, yes, it does, but of course it's related to ohms. But the select, you've got different functions now. So if I press this once, we go into diode mode. So let's just try that. You've got a little symbol of diode there, says diode there, and it's telling me the forward voltage drop there. And let's just bring in a few diodes here. Right, I just put my lighting back on up here. It's the battery had died. So yeah, a few diodes. Let's try a small signal diode. So we've got 4148 there. Let's try that. So put the leads round. Oh, that's the wrong way round. That way round. Okay. And what we're getting, 0.621. So that's the forward voltage drop of that diode, and the diode is good. Okay, so that's that one. Let's try a different type of diode. Let's try a Schottky diode. How did it cope with that? I haven't done this testing yet. In fact, this bag isn't even opened. So let's get that open. So this is a 1N5822. So let's try that. Yeah, so as expected, the forward voltage on a Schottky diode is much lower, 0.177 volts. That's brilliant. Okay, put that back. Let's try a Zener. That'd be interesting. So this is a 3.9 volt Zener. They're dirt cheap ones, so I don't expect them to be accurate anyway. So let's just try the forward voltage first. 0.73 volts. Okay, now I wonder if it'll tell me this. I'm not sure it'll go up to that voltage. 2.7. So that probably is right, because these things only regulate to that voltage at a certain current range. So yeah, not really of much use, but you can see this does break down in reverse bias at a lower voltage. So that would indicate to you straight away it's probably a Zener or a damaged diode, I suppose. But you should really know what diode you're dealing with. Let's try something else. What have I got? Rectifier diode, something a bit more meaty. Yeah, again, these aren't even open. Don't know why I've got these, so let's open them up. Probably had these for years. So Again, put it the right way round. And 0.564 forward voltage drop. Okay. And let's just see how it copes with LEDs, because I use the diode mode quite a lot when I'm soldering LEDs into a board, because I want to know how they work before I commit to soldering them. So let's just try that. Yeah, that's illuminated. Brilliant. Okay, and it's putting 2.5 volts through it, or 2.6 volts through that. Great, let's just try it the other way around, see what happens. Yeah, of course, it's open circuit diode. All right, brilliant. So that does work. I can use that to test my LEDs. Let's try a larger size diode. We'll try red this time. And get it around the right way. I think that's the positive there. And negative there. Yeah, that is just illuminated. You can just see. Brilliant. And a 1.7 volt there across there. Okay, so that's diode mode. And when you're in diode mode, if you press the F3 or the select key once more, then it goes into continuity mode. Now for this, my microphone that I'm talking through is attached to me on my shirt. So I'm going to just put another microphone over here just to make sure you can hear the buzzer. I'm not sure if you can through my current mic, but these are just double up. You might get a bit of echo from my voice now. So I've got my Probe Masters actually. So let's just see how quickly this behaves in the continuity test. So you've got ohm symbol there, you've got a little speaker to tell you it's in continuity test, and indeed it says continuity up there. So yeah, it's got an LED and the buzzer, and that is quick. Very quick. Let's just try that with the leads that came with the meter. So here we go. These are the leads that came with the meter. Now they've got these plastic caps on, so I'm going to take those off for this. And let's try now. Yeah, see the difference between gold-plated, high-quality probes and the ones you get free. It just misses it every now and again. In fact, quite often. If you hold it, it's fine. It works to a degree. But yeah, I'd really recommend you invest in some quality probes, and you can use those probes on any meter you've got then. I'll tell you what I'm going to do. I'm just going to try cleaning these a bit. So I'll use some isopropyl. Let's just give this a go, see if it makes any difference. Get my cloth under there. Okay, so they've been cleaned with isopropyl. Now turn this microphone on again. You can hear it better. Now let's try again. There you go, look at that. It's not quite as good as a Probe Master, but cleaning them with a bit of isopropyl, so it may have had, I don't know, some kind of grease or something on there. They were brand new out of the box, by the way, but that's made a big difference. So that's a tip for you. If you clean them with isopropyl alcohol, then it can improve the performance of your leads. So that is continuity. And just to show you the use of this save function in resistance mode, so I've reconnected the 100 ohm resistor there, getting a reading of 100.1. If I press that again, hold it for a couple seconds, there's all the entries again. There's the 5.005 volts we recorded previously when we was in volt mode. Now if I move this arrow down to position 1 and click save, there you go, it's recorded my 100.1 ohm resistance reading. Brilliant. Then to go back, just hold again for 2 seconds and it will go back to there. And if we click around once more to capacitance, then the LEDs you can see goes to this red colour, and the only function you get is rel or relative. So let's take a look at that and see how that performs. So I'm on the capacitance selection option there. It's a big C, little x. It says capacitance at the top, and it's obvious it's capacitance because it's giving you a reading currently in nanofarads. It's in auto range, of course. And it's picking up some capacitance of these leads. It's 0.16. If I move it about, it probably change. Yeah, it's moving a bit. And you could probably eliminate that out by using the rel function again. Now I've only got cheap capacitors here. I think got a couple more expensive ones, but let's just see how it performs. It's more to do with really how quickly the meter establishes the reading, because in my experience most meters take quite a while to settle down to get the range right and stuff. With capacitance it's a bit more difficult to measure than your voltage or your normal DC resistance. Let's start off with a 1 microfarad then, see what that does. These are electrolytic capacitors, and 1 microfarad, so stayed in the nanofarad range, but you can see it's nearly 1,000 nanofarads, so that is 1 microfarad. Okay, let's go up the other end. Let's try 1,000 microfarad. This is likely to take longer, I would have thought, but let's see. When I say longer, I mean longer to establish and settle down. Let's try that. Let's change range. Yeah, not bad. So that was pretty quick. 940 microfarad, and it's classed as 1,000 microfarad, but these things are never accurate anyway, these cheap ones. This is probably a bit more accurate. What is this? This is a 2.2 microfarad. Yeah, this is what we use in speaker circuits to block out the DC current. So let's just put this here. Yeah, that's more accurate, a bit more of a quality capacitor there, so that's reassuring. 2.26 microfarads, that's good. So it's rated at 2.2, brilliant, and it says on there actually it's plus minus 10%, so that's probably within tolerance. Let's try something a bit smaller. Or yeah, 470 picofarad. Let's try that. So it connects with something really small. Oh, well that. Oh, it's bang on. Is it 470? Yeah, 470 picofarad. Bang on, 470 picofarad, or 0.47 nanofarads. That's pretty good. So at probably the lower capacitance, it copes better. So that's it. That's capacitance. Okay, and click around once more and we go to frequency. And in frequency mode, the only button that's functional is F3, which is the select button. So when you press F3, you can go between frequency and duty cycle. So let's take a look at that. Right, so I'm in frequency mode, there you go, and I've got it wired up to my signal generator over here. And I've got my signal generator on a sine wave at 5 volts peak to peak, and it's set to 10 kilohertz. And look at that, bang on, 10 kilohertz, that's the reading I'm getting. So if I now adjust this, let's take it down 1 kilohertz at a time. 9, 8, 7, that's quite impressive. 6, 5, 4, 3, 2, 1. That's bang on. Now let's just try going up the other way. So I don't know how high my signal generator goes. We're at, let's get it to 50 kilohertz. 50 kilohertz, okay. Let's go up 100 kilohertz at a time. 150, 250, 350, 450, 550. I'll tell you what, let's take it back down to, round this up again, and let's go up into the megahertz. 1.5 meg, 2.5, 3.5, 4, blimey. So let's go up as far as we can. 15 megahertz. That's what this is set to. You see it, 15, out of focus, 15 megahertz there. That's very good. Let's try some lower frequencies then. Let's get this back down to 0. And right, see if we cope with this. So that's 1 hertz. Yeah, lower. It's got 1.6. Let's try 10. 9.999, good. And 20. 19.99, not bad. Okay, I've now changed my signal generator to be a square wave rather than a sine wave. Don't know if you see that on there, square wave. And I've got it set to 1 kilohertz and bang on 1 kilohertz. If I go up in steps of 1K now, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Brilliant. That's working very accurately again. Now, if I change this, if I press the select key here, the F3 key, then it goes into duty cycle, and it's currently my signal generator is at 50% and I've got 49.97. So if I start to adjust my duty cycle, so I'm currently at 50, I'll go up in steps of 10. Oops, sorry. So there you go. 60. Okay, 40. 70. We're getting 30. It's back to front. Okay, that's interesting. Is that the meter? Because this is the percentage of the highs versus the lows. So my signal generator is telling me that it's on 20%, and this is the opposite. It's the inverse. This is working upside down. But let's just check something. Right, yeah. So I've just proven what that was. So I'll put my meter back to continuity, and I've got my probe masters on here now. And I suspected this little adapter here, is it back to front? Because you would expect this red here to be connected to the center pin of this BNC and the black to be the shield of it. But if I connect this to here, the shield, and connect it to black, nothing. Touch that to the red. As you can see here, look. Touch it to the red. This is back to front. You'd expect this to be the other way around. So let's now try it that way around, which looks a bit odd, but we'll try that. Okay, second time lucky. So I'm roughly at 50%, which is the duty cycle set on my signal generator here. Let's go up to 60%. Yeah, that's better. 60, 70, 80, 90. Yeah, let's go the other way. Down to 10%. Yeah, that's more representative. So that's interesting. That's back to front to what I thought it should be. Okay, so that is frequency and duty cycle, which is similar to the frequency and duty cycle setting you get when you're in volts mode as well. And if we click around to the next setting, then that is the microamp range. And as I've shown there, you must connect your red probe to this socket. It says out and milliamps, but it's also needed for the microamps range. The functions are very similar, so F1 is still your relative function, F2 is still the peak hold, F3 allows you to select between DC and AC, and F4 is your range selection function, and of course you press auto to get back into the auto mode. So let's take a look at that on the bench. So I'm on the microamp setting here, which is a little micro sign and amps, and it says here DC microamps, and you've got current stated up there. Now I've got nothing really to inject anything down this low, certainly not accurately anyway, unless I build a special circuit, but I just want to demonstrate this, how it operates. And you have to put your red lead into the milliamps socket here. So that's milliamps and microamps range. Okay, so all I can do, I was going to use my constant current regulator here, but this won't go down that low and it's not that accurate. So all I can do is use my bench power supply and change the milliamps on that. That's the only resolution I can go down to. This is in microamps. So my bench power supply, and this won't be accurate, is at 1 milliamp at the moment. So I'm getting 1600 microamps. That's probably more accurate than my bench power supply. So let's go to 2 milliamps, 3, 4, 5, 6, and there you go, 6, because we've reached 6,000 count. So, and of course I'm putting in milliamps as opposed to microamps, so you're not seeing very much resolution at all there. But yeah, it's the best I can do on that one, unfortunately. Let's try out the milliamp range. And if we click around one more, then we go into the milliamps range. Not a lot of difference. In fact, the functions on here are exactly the same. The range is slightly different. And let's just take a quick look at measuring milliamps then. Right, so I've gone around to milliamp, and you can see here it says milliamp, still says current, and I'm putting on my power supply 1 milliamp, and this is telling me I'm getting 1.6, but that's not the meter. It's that my bench power supply can't really control the current that low very well. So let's just gradually creep that up. So 2 milliamps, 3, 4, 5, 6. Okay, let's get it right up now. 20, 30. I want to get it to the next range. There you go, it's jumped. So I'm going to drop back down again. 55, 58, 59, 60. So this, in this instance, it's gone over the 60.00 count. And it does that to avoid, you know, chopping and changing range so rapidly, which would be off-putting. So it does give you a little bit of a window, but it'll eventually go to, yeah, there you go, it's dropped 1-digit resolution now. So we're at 600.0. Right, so that's milliamps, and you can change this to AC or DC, of course, and all this works the same as the others. And you can, of course, use the save button, and you could have used that in the microcurrent as well. So let's save that away there. And nice, 065.9, and it's got the little milliamp symbol. Brilliant. And the final option on here is your 10 amp range. And when you're on the 10 amp, you must move your red lead to here. If you leave it here, you're likely to blow the fuse inside this meter or damage it. So if you're dealing with high current, make sure you're in that 10 amp socket, not the milliamp socket. And the functions are very similar. F1 is your relative function, which you can turn on and off. F2 is your peak hold, which is shown there. F3 is select to allow you to switch between DC and AC modes. And F4 is your range. And of course, you use the auto button to get back to auto. And let's take a look at that on the bench. So there you go. I'm in the 10 amp range selected there. It's telling me current and DC amps. I can change that to AC by pressing the select. And make sure you put your test lead into the 10 amp range connection there if you're dealing with higher current. Otherwise, you'll blow the fuse inside the meter. So again, I'm just wired into my power supply, and I've got it set to off at the moment, and it has 0.001 amp. So let's just go up by 1 amp at a time. So that's 1. Sorry, turn it on. So that's 1 amp. Okay, get 1.002. That's good. 2 amps. 3 amps, fans on my power supply kicking in, and again we can save that away. So I've got 3.0023 amps there. Click the save, or hold that down 2 seconds and move down and press the save button there, and it stored it away. If I wanted to get rid of that, there's an erase button there, but let's just restore it back there, and let's come out of that, and we're back. Okay. And that's it. That's all of the options on there. If you click it round one more, then you've got the secondary off position, which I quite like. It means you don't have to go all the way back round to there. But let's just now go back round to the volt selection. And if we press and hold this auto button for 2 seconds, then we go into the oscilloscope mode. And when you're in oscilloscope mode, you must connect your red lead here and your black lead here, of course. And the function buttons behave like this. F1 allows you to adjust the time base. That's the time for each of these divisions, and you can set a range using these left and right arrows. You can set the range from 200 nanoseconds right up to 10 seconds. The F2 key is volt, and that's the divisions there, what the voltage representation of each of those divisions are. And you can go from 500 millivolts up to 200 volts. The F3 key is your trigger settings. So this one allows you to change from rising edge or falling edge, and mode allows you to adjust between auto, single or normal. And I'll explain what they are when we go to the bench. And you've got level, which allows you to adjust at which voltage level you will trigger at. And you'll get a little triangle down the right hand side here. Then F4, well, that allows you to change between AC and DC coupling, and I will explain that. And just to show you, the display on the scope gives you all this information. So this is your coupling here, currently at DC. You can switch that between AC and DC. This is your time base, so that's 500 microseconds per division. Channel 1 is set to 1 volt, so that's 1 volt per vertical division there. This symbol means the trigger is set to the rising edge. The mode of the triggering is auto, yeah, and that's your battery indication there. And down the bottom, the button, you know, F1 is time, F2 is volt, that's shown in blue in this mode. Then you've got your peak-to-peak voltage, your average voltage, your RMS voltage, and the frequency that's been detected. So let's go and have a look at that on the bench then. So there are two ways that you can enter the oscilloscope mode. You can be in the volt selection here and then hold down the auto button for 2 seconds. And that defaults the voltage per division here as 200 volts. If I go back and selected the millivolts range on the selection wheel and then press the auto button for 2 seconds, now it's 200 millivolts per division. So that's nice. It sort of enters into the appropriate range that you've got selected here. So I've just zoomed in for you a bit there. So along the bottom, you've got the F1 key is your time setting for the time division here in the time domain, volt setting, the trigger setting, and whether it's AC or DC coupled. Along the top is your time division. So these are 10 milliseconds per division, your voltage per division, this scale, so it's 200 millivolts currently, and your trigger end mode, which we will come on to. So as I said early on in this video, using these type of test leads for an oscilloscope is not really ideal. They've got capacitance and inductance and all kinds of stuff, and oscilloscopes don't really like that. And I see other people have commented on this that that's a weakness, but actually there's a fairly simple fix, and that's to use one of these, a little cheap banana to BNC adapter. Now, I'm not going to fall into the same trap and find out that these are wired back to front to what I thought. So let's just check that, see how it's actually wired. So the center pin is positive, and the outer shield, of course, is what you refer to as the ground. So let's just go into continuity then, and let's test that. So we'll go on the center pin there. It's not that leg, it's that leg. Okay, so that's the positive leg there. So this, therefore, should fit that way around into there. Perfect. Now I've got BNC, and I can connect my scope probe, which you can buy separately if you haven't got one, and make sure if it's a 10 to 1, 10 times or 1 times switchable, that you're in the 1 times setting. Okay. And then that will connect on to your adapter like that, and you've got a normal scope probe. So I'm going to connect this now to a test output that's on my other oscilloscope, and let's see what we get on here. So there you go. I've connected this up to my bench oscilloscope to the output that's used to calibrate your probe. Okay, and that is a 2 volt square wave that it's giving out, and I'm getting something here. Let's just change the time domain now. So I'm at 10 milliseconds per division. Let's change that so we can see the wave better. There you go, nice square wave. Exit. So it's shuffling about a bit because the trigger here is set right at 0 volts. If we bring that up a bit, it'll probably stabilize a bit more. So we go into trigger and level. We can now move this little triangle up and down. So let's take him up. There we go. So it's just increased the threshold a bit, and now it's stabilized. Got a nice square wave, 1 volt per division. So this is 2 volts peak to peak. Down here it says 2.12 volts peak to peak, or 1.04 average, and that's a 1.4 volt RMS, and it's 1 kilohertz frequency, which is bang on. That's what my bench oscilloscope is giving me. So just in case you're not really familiar with some oscilloscope terminology in terms of the triggering, I'm in the triggering mode now. So you've got this button F2 has got kind of a symbol next to it like this. Okay. And this basically allows you to select whether you want the trigger to be on the rising edge or the falling edge of the signal. So that means the voltage is coming down past your threshold or moving up past your threshold. And by threshold, I mean your trigger point that you set here. This is the voltage trigger. So if it passes up past that and you've got it set to rising edge, it will trigger. If you've got it set to this one and it goes down past that, it will trigger. And triggering basically means at the center point here, that's when it will capture the waveforms. Anything that just preceded that will be displayed, and anything just after that will be displayed, because this meter has got memory, the oscilloscope's got memory, and it can plot that waveform. So on this F3 mode option here, you've got auto, you've got single, and you've got normal. So in auto mode is exactly as I said, it will trigger based on whatever you set this to. So it's either on the rising edge past the given threshold or on the falling edge of a given threshold. So if I set my threshold, say here, and let's say this was the 0 volt line here, and my waveform went, so I'm on the rising edge and my waveform kind of went like this, it would trigger at this point, okay, because that's the point it crosses the line, and then it would center that and give you a bit before and a bit afterwards, so you can see the bigger picture of the waveform. And if you set it to, yeah, and it won't redisplay that until another trigger event occurs, and then it will update the waveform again. And if you set it to single mode, then it will wait for one of those instances to occur, put it on the screen, and that's it. It'll leave it. And that allows you to capture and properly analyze that waveform without it keep chopping and changing all the time. So if you know that the waveform is consistent, like a sine wave, you can just do a single shot and then put it on the screen. You can zoom in, zoom out, change the voltage scale and the time domain scale, get some measurements off of it and all good stuff like that without it keep changing because it keeps triggering. So that's single shot. And in normal mode, well, that will keep redisplaying every time it passes through the whole display cycle. So whatever time division you set per these divisions, that's got a time to sweep all the way across. Then it'll have a hold off period. We don't know what it is on this meter. There'll be a small hold off period, and then it will just trigger anyway and redisplay the image. So that's kind of it sweeps the signal and then comes back and does it again, okay? And back in the main menu now, I've come out of the trigger option, F4, which is AC DC option, which I press F4 and it changes up here on the top left. Probably can't see that on the camera. But the difference between AC and DC I'll just explain. And that's the coupling of your input here. So if I've got a waveform, and let's say it's an AC waveform, but it's got a DC offset like that. This is my 0 volt line here, let's say. But I don't want it like that because I'm losing some detail. I want to eliminate the DC offset and bring it back down to here so I can view it properly. All right, so the way you do that is, let's say you've got a scope probe like I will have, but you could be using your test leads instead, doesn't really matter, same principle. Try and draw a probe, something like that. This comes in, and of course you got the sort of positive input, if you like, and then the ground that's going into your scope here. And then this coupling here will either go something like this. There. So that's that, right. So when you select AC coupling, it takes the signal through a capacitor that's integral into your meter, and that capacitor basically blocks out all the DC voltage of what's coming in, and it will bring your signal down to be centered. If you put it to DC mode, then effectively this flicks over to here internally and it couples straight through, so you do see the DC element. Let's just have a look at that in a demonstration. Okay, so I've got my signal generator out again, and I've got it set to 1 kilohertz, which it is telling me down here, exactly 1 kilohertz, and I've got it 5 volt peak to peak or something like that. And so I've got my sine wave here, but you can see it's offset, it's lifted up, and I can't see all of the sine wave. And that's because on my signal generator, I've set it to a 3 volt offset. So it's got a DC component to this of 3 volts, and then your AC signal is alternating up and below that. So I could bring this back to here and just look at the AC component, because it's only the AC that will pass through that capacitor. So if I go back here and change to AC, there you go, brings it into the middle. I'm only looking at the AC element of the signal. So probably the most important factor with an oscilloscope is its bandwidth, and this is rated at 12 megahertz. And what that means is after 12 megahertz, you expect the voltage to drop off in your measurement that you're getting on your display here. So if you look at it like this, you've got a graph and you've got frequency here, and that looks like a G, that should be a Q, and you've got voltage along here, then initially the reading that you're getting is sound, it's good, it's the right level. But what happens, because of capacitance and all kinds of stuff and the way the meter works, it starts to curve off, okay? And the bandwidth is basically the point at which this curves off by -3 dB is the common way of gauging that. So given dB, when you're talking about voltage, of course, it's 20 times the log of whatever voltage you got over some kind of reference voltage. So we're going to establish a reference voltage and then keep measuring until this drops by 3 dB. So what is that 3 dB drop point? What voltage do I need to see at a given frequency, or a frequency that I'm going to adjust to determine what my bandwidth actually is? So I'm going to use this here. So I've got 5 volts peak to peak. I've got a 100 kilohertz sine wave coming in from my signal generator, and that is set to 10 volts peak to peak currently, but I'm only getting 5 volts peak to peak. So why is that? Well, that's because I put a terminating load here, and that's the correct way to measure your bandwidth. So there's a terminating load here of 50 ohms, and the output impedance of this meter is also 50 ohms. So 50 and 50, it's that term voltage divider again. Look at some of my previous videos if you want to learn about voltage dividers. But basically 50 and 50, that means I'm going to get half the actual output voltage. That's why I'm getting 5 volt peak to peak here. All right, so I'm going to start off at this. I'm 100 kilohertz, so 100 kilohertz is well within this 20 megahertz bandwidth. Won't be a problem at all. So I'm going to take that as my reference, as 5 volts. So therefore I can replace this with 5 volts here, and whatever reading I get on here, if this reduces, then my dB drop is basically going to be based on this formula. But I'm going to do it the other way around. I'm going to work out, well, what voltage do I need to drop to get to establish a -3 dB? Well, it's basically the inverse of all of this. So first of all, 3 dB, it's 20 times. So if you take 3 and divide it by 20, you get 0.15. Then you need to take the inverse log of that. Well, the inverse log is actually 10 to the power of 0.15, which gives us 1.4125. Then you do the inverse of this. So 5 over 1.4125. It's long-winded, I know. 3.5398, that is. So that's what we're looking for. Let's say 3.54 volts. That's when this starts off at 5 volts and I drop down to 3.54 volts. That is my -3 dB. But actually, much simpler way. You don't need to do all of that malarkey, but I was just running you through the maths of it. There's a much simpler way. You can take your reference voltage, which is 5 volts, and multiply that by 0.707, which is basically 1 over the square root of 2. Right, so I'm currently at 500 kilohertz, and we are at roughly 5 volts peak to peak still. So I'm going to start increasing the frequency, and I'll adjust the time domain setting on here just to keep the sine wave within a nice display. So if I go up, big step, 1.5 meg. It's telling me it's 1.5 meg here. Did it drop at all? So we're sort of here. It doesn't appear to have dropped. Let's try it, 1.5 meg, yep. So it's still telling me it's 5 volts peak to peak. Let's keep going up faster. We're at the limit now of the time domain. We're at 200 nanoseconds. So that's 5.5 megahertz, which is saying down here. It's still telling me it's 5 volts peak to peak, which I'm not sure that's correct. Let's just drop down. Yeah, no, it's still solid there. There we go. It's dropping down at that point. You see the sine wave's getting smaller. So I'm currently at 11.5 megahertz now. And what have we got? 5 point something, 5.1. The voltage has gone up according to that. That's incorrect. I don't understand that at all. So I'm going to do it by this gauge. That doesn't sound right. So what are we looking for? We're looking for 3.54 volts. So roughly 1.5 would be there, because it's peak to peakles. 1.5 would be there, somewhere about there. It's really rough and dirty, this, but let's just see. So we've got to get down to roughly that point. And actually that's the limit of my signal generator, and it's actually at 15 mega ohms. So according to the scale on here, it hasn't even reached the 3 dB drop, but according to this, which I think is lying, that I don't know why that's telling me it's still 5 volts peak to peak, because it's definitely dropped. Okay, so that's, to me, it's confirmed the bandwidth is within its specifications. And by the way, I'm using coax here. It'd be different if you use your test leads. You'll get less bandwidth with that. But yeah, not too happy about that voltage peak to peak reading. Don't quite understand what that's about. So you go, that's the oscilloscope mode, and you've got to take this for what it is. It's a low-cost handheld device. It's not going to perform like a bench oscilloscope, which is going to cost you many hundreds or many thousands of pounds. So you've got to expect that. Now, I will do another follow-up video on this, because I'm interested to see how this performs in audio. Can I detect audio clipping in here? Because that's one thing I'm certainly interested in, because I'm often on site and you're trying to listen by ear. But if I've got a handy little oscilloscope in my kit bag and I put it onto the output and try and put a sine wave out through the speakers or through the amplifier, and see if I've got clipping, see if it's flatlining on the top and the bottom of the curve. I will try that. I'm pretty certain this will hold up well to that. Anyway, let's move on. So that's the oscilloscope covered, and now if we go back to the volt mode here and we hold this button for 2 seconds, then we go into the signal generator mode and the display looks something like that. So the function keys now, you've got F1, which is the waveform. You've got this up and down arrow, allow you to select between sine, square and ramp. F2 is the frequency, which you can go up with this one, down with this one, and you can go from anything from 100 Hertz to 100 kilohertz. And you can actually jump straight into the volt setting now with that. As here, you could have jumped straight into the frequency setting as well, but we'll go through it this route. F3, that is the duty or duty cycle. So you go anything from 10% to 90% using these up and down arrows. And F4, that is the voltage, the peak to peak voltage of whatever waveform you're triggering. So it goes from 0 to 3 volts. So let's have a look at that now. Okay, so to use the signal generator on this, you have to put your red lead into this port here. It's got a little symbol there, the AC sine wave, and it says out, all right? Now, unfortunately, this adapter doesn't fit. It's not quite the right spacing, so I've had to do it this way, and I've gone into my escape using one of those jacks that side, all right? So the way to get into the signal generator mode is you go into either of the volt settings and you press and hold this. There's the symbol there on the button. So if I hold that for 2 seconds, there you go, I'm now into signal generator mode. It's defaulted to a square wave, as you can see, and it's 50% duty cycle, and it's 3 volts peak to peak. So I'm at 1 volt per division, so 1.5 there, 1.5 here. Yep, that's 3 volts peak to peak. If I want to change the wave, I press F1 where it says wave, and then I can go up and change it to a sine wave, or I go down and change it to a ramp. Nice. Let's go back to, say, sine wave, and we'll exit there. Now let's go into frequency and play around with that. So we're currently at 1 kilohertz, and that's what I'm reading here. Let's go up to 2 kilohertz. Hasn't changed yet, so I think you have to exit. Yeah, when you exit, it then changes it. Let's just increase my viewing scale there. Let's go up some more. So let's go right up the top here, 100 kilohertz. So exit, bang. Let's change my scale. There we go. And let's change the vertical scale as well. Okay, so we are getting 100 kilohertz. Brilliant. What else can we do? We can, let's put it back to square wave. There.
exit. Yeah, a bit not quite so square there because we're up at higher frequency, of course, and all this doesn't help. So let's drop the frequency a bit just to give it a chance. Let's go to 2 kilohertz and zoom in on that. Yeah, that's a bit better. We'll reduce the vertical scale for this one. And let's try this duty cycle. So on the duty, we're at 50%. Let's go up to 70, press exit. There you go, it's changed. And then if we go to duty and we go down to 10%, exit, there you go. Now you can see I've done this again. I've gone wrong with this adapter. Yeah, this is back to front. That's why it's showing like this. It should be the other way around. There you go. I swapped it as it was when I had it on the scope. It's around the right way. Actually, let's try something. Yeah, as I thought, these come off. So let's swap these around. There we go, 10% duty cycle. All right, that's better. Let's try something else now. Let's go the other way again, just to check that's right. Let's go back to 50 and exit. There we go, 50% duty cycle. All right, that's cool. So that is a complete test drive of the Gochifix LG303. As I said, they don't sell it in the UK at the moment. I will put a link in the description below. If you're in the US, use that link. And if you put in this discount code, you will get a further 25% off. Okay, so that's the end of that video. If you did like it, then please click the like button. And if you haven't done so already, please click subscribe too. All right, catch you later.